Let's talk about dilation. So what is a dilation? This is the last and probably one of the easiest transformations that we'll talk about. But a dilation, it's just a transformation that enlarges or reduces a figure. So it creates a similar figure, meaning it's the same proportion, it's the same shape, it's just bigger or it's smaller. So in a dilation, the figure is enlarged or reduced to a fixed point called the center of dilation. Now, the scale factor of a dilation is the factor that you either multiply by or that you divide by when you're changing the size of the figure. So it's the ratio of the side length of the image to the corresponding side length of the original figure, which was the pre-image. And those corresponding sides would be proportional. All right, let me give you just a quick demonstration of what this means. So if I have a triangle and I want to enlarge this triangle, okay? If I make it bigger, let's say the original triangle had a side length of 2 right here. And I enlarged it, and now that side length is 4. When we say that something's proportional, that means, so if I started at 2 and it became 4, it got twice as big. So the same would be true if, let's say, this bottom one to begin with was 3. Then we would have to double it when it increases or when it gets larger. And let's say this side was also 2. Then this one would also be 4. So to say that something's proportional, it just means that it keeps that same multiplication factor or division factor from one to the next for all of the sides of that figure. All right, let's talk about coordinate notation for a dilation. If you are dilating a single point xy, you're simply multiplying that point, the x and the y value, by the scale factor. Now, the scale factor, we call that k. So it's the scale factor times x and the scale factor times y. So a reduction would be when your scale factor is less than 1 but bigger than 0. You won't see negative numbers in here, so between 0 and 1. And for an enlargement, so if your figure gets larger, that would happen when k is bigger than 1. Don't worry, we are going to do some examples. First, we're going to look at enlarging a figure. All right, example 1. Draw a dilation of triangle ABC with vertices. Vertices just means the points of the triangle, A, B, and C. Use a scale factor of 4. So this means our k is 4. So if k equals 4, that tells us that every point xy is going to be transformed by being 4 times the x value and 4 times the y value. All right, so our point A is 1, 0. So we're going to multiply 1 times 4 and 0 times 4. And we'll call this point A prime. Point B is at 3, 3. So that's going to be multiplied by 4 for both of those. So B prime is 12, 12. And point C is at 3, 1. Multiply both of those times 4. And now we have the vertices for our enlarged figure. All right, example 2 is kind of going in the opposite direction. We have our two figures, our pre-image and the image, and we want to know what is the scale factor. So we're kind of working backwards. All right, let's start by listing some of these points. The original point A, notice where the origin is. Here's our origin. So A is at the point -1, 0. And A prime is at the point -3, 0. Let's look at points B. Originally it's at 1, -2. And B prime is at the point 3, -6. So after we've done a couple of these, you might be able to start seeing a pattern between the original vertices and the prime vertices. Let's keep going with point C. That's at the point -1, -4. And C prime is at the point -3, -12. And finally, for point D, -2, -3, and D prime is at -6, -9. So let's look at what happened. So our original x, y coordinates were transformed to be some number times x and some number times y. So we want to look at how to get from one coordinate to the other. So to get from -1 to -3, that would be a multiplication by 3. To get from 1 to 3, a multiplication by 3. So for all of these, you can see that for every x coordinate, you're multiplying by 3. The same goes for the y values. 0 times 3 is 0. -2 times 3 is 6. -4 times 3 is -12. -3 times 3 is -9. So each x value and each y value was multiplied by 3. So that's our scale factor. Now let's look at reducing a figure. Okay, for example 3, draw a dilation of quadrilateral ABCD with the vertices listed there and use a scale factor of 1/3. So our K is 1/3. That means that 1/3 is what was multiplied by each of the coordinates to start with. All right, so let's start with A. A is originally at the point 0, 12. And A prime is at the point 0, 4. So A prime is going to be 1/3 of both of those points. So 0 divided by 3, or 1/3 of 0, is still 0. And 1/3 of 12, or 12 divided by 3, is 4. for point B. B is originally at the point 9, 9. And B prime is going to be 1/3 of both those values. So 1/3 of 9, or 9 divided by 3, is 3. And the same for the y value. So notice that now B prime overlaps with where the original D was. That's okay. It'll happen. C is originally at 12, 6. So C prime is going to be 1/3 of both of those. So 12 over 3 is 4. 6 over 3 is 2. Point D was originally at 3, 3. D prime will be at 1/3 of those, so 3 divided by 3 is 1, giving us the point 1, 1. Now this figure is a little bit oddly shaped because it's so small, or it looks like it's kind of oddly shaped because it's so small, but that's okay. So it's the same shape, it's just 1/3 of the size of the original one. Example 4 is going to be going in the opposite direction. We want to find the scale factor given the image and the pre-image. Okay, so point A starts out at the point -5, 10. And A prime is at the point -1, 2. So I'm just going to continue listing out all of these points, and then we will look at what the pattern is between the original points and the prime points. All right, so I've got all the points listed here, and we want to look at how did our x's change, and that's going to be the same as how the y's changed. So from -5 to -1, that would be division by 5. 5 to 1 is division by 5. And -5 to -1, again, division by 5. It's a little bit easier to see between 10 and 2. If I were having to multiply or divide 10 by something in order to get a 2, 10 divided by 5 gives me 2. So since you are dividing by 5, is the same as multiplying by 1/5. So our scale factor is 1/5. Our original points became 1/5 of what they were.